All right, so you're going to want to keep in mind here that the instructions do state that you may need to individually select organisms because the way the BLAST works is that it tries to give you high quality matches. So it's trying to find things that are very similar to your input sequence. And as a result, that means that when you look for distant comparisons, like for example, Saccharomyces cerevisiae, also known as yeast, is quite different from Arabidopsis thaliana, which is a tobacco plant. And both of those are actually very different, as you might surmise, from Bos taurus, the cow, or us, Homo sapiens. And we want to compare all of these broadly divergent sequences because they all still have the same gene, and looking at the same gene in evolutionarily distinct organisms is an interesting way of understanding what parts of this protein encoded by the gene are important and how it may have evolved and its function. We can learn a lot by looking at divergent proteins this way. So here you can see that I'm individually selecting the species that I want to focus my search on, because otherwise BLAST will cut off a lot of these results, which is why you're not seeing all your matches when you look at a window like mammals or even vertebrates or even all metazoans, for example. You need to specify this, right? So here you can see me building my custom search using that NP underscore sequence that I got from the human PGK1 gene search and against the RefSeq database, and just individually specifying all 12 of the sequences that I want to see in my results. And so BLAST will take some time here. If you've already watched this far, you should be able to see my search ID soon in the results page. And when you see that, you can easily use that reference code to jump straight to actually the exact BLAST results that I obtained. And here you can see we're finally at the results page, and you can see there's a little information blurb that's popped up at the very top of the results saying that your search is limited to records that include all the species that I selected. And scrolling down, you can see it's a much smaller results list that actually does contain one hit at least from each of the species that I specified. And you want to be careful here because there are other forms of PGK, right? So you see there, I almost selected PGK2. Make sure you don't do that, except for, I believe, it's Saccharomyces cerevisiae doesn't have PGK1 or PGK2. There's just PGK. And that's because they haven't found PGK2 yet in Saccharomyces cerevisiae. It might not have PGK2, but there is a PGK, and so we'll just take that one as PGK1. You can see Arabidopsis thaliana actually does have PGK1, so you can begin to build sort of a rough understanding of evolutionary relationships even just by looking at a small microcosm like this, the PGK1 gene, across 12 different species. So now you can go ahead and select these sequences and download the alignment FASTAs, and now you can complete the assignment.